Well, good morning, students. In the previous class, I had discussed about the Nernst equation and for half cell and the complete cell to calculate the cell potential of the cell. Now we take the and I had also given the example how to solve the numerical. Now when the stoichiometric, that is the charge on both the ions will remain the same. If charge and are the different, then how we will solve it? We take an example. As for example, similarly the question is E naught Ag plus Ac, and that is equal to plus 0.80 volt given, and E0 copper 2 plus copper, that is plus 0.34 volt. Is it clear? And this is Ag plus concentration. This is aqueous. These all are aqueous. Is equal to 0.01 m. And this is copper 2 plus concentration is equal to 0.001. Right? So, question: from the data, represent the cell. Write the half cell and the complete cell reaction and calculate the cell potential of the cell. E cell we have to calculate it. This is we take the another example, right? So what we do first, in the previous class I had discussed you how we will represent the cell, keeping in mind the higher value of reduction potential. The half cell is represented on the right side. So this is right side, Ag plus and Az. This is very important. And in the, if it is reduction, always in the right, reduction takes place, the in another electrode oxidation will take place. So the oxidation, copper will get oxidized to copper ion, and we write here aqueous and this one. Now these concentration are given. It is given in the question paper 0.1 m, and this is 0.001 m. So this is the cell is represented. Half cell we write it copper 2 plus. This is twice here. So we see this is a half cell and this is also a oxidation half cell. This is reduction half cell. Here the charge is 2, here the charge is 1. So it will get 1 electron and get reduced. So we have to equalize the electron here. That's why I have taken such an example in order to clarify the concept. So it should be multiplied by 2. That's why it is written as 2 whole equation. So the net cell equation, now we write copper, and this one is twice Ag plus, and this is equal to copper 2 plus, this is aqueous, and this one is twice Ag solid. So the question represent the cell, right half cell, each half, that is oxidation half, reduction half, and this is a redox reaction. Now E0 right, E0 cell we calculate earlier, that is E cathode minus E anode. E anode. This is what is the topic here, NERNST, Nernst equation, for to calculate the cell potential of a cell having different different charges, different valencies on the metal ions, right? So NER, NST. In the previous class there was a slight spelling N was not given in the previous classes, so we will rectify it or correct it. So E cathode minus E anode. What is in the cathode side? E0, Ag plus, Az, and in anode side E0, copper 2 plus, this is copper. So we put the value 0.80 volt minus, and this is plus 0.34 volt. We solve it, it comes to be 0.46 volt. So our one step is complete. Now we apply the direct step E cell, E0 cell minus 0.059. Need not to write that is 2.303 RT by NF, log product by reactant. In format we written log product by reactant. This is very simple. Reactant. I have written here the net equation, and we are applying the Nast equation on this equation to calculate the cell potential of this cell. So we again write E0 cell minus 0.059, and the value of N. Why it is needed to be multiplied? And because a common value of N, electron lost and gain should be same. Here it is 2, that's why it is 2. So we write the value is 2. If comes here, here is 3 and here is 2. So you will multiply the each half by a suitable number so that the total electron will remain the same. That's why we put the value of this one. So this is log. What is in the product side? Copper 2 plus aqueous, and this is Az. Applying the concept of law of mass action, and in order to write the value of the equilibrium constant, how we will write it? AA plus BP is equal to CC by dt. Then Kc is equal to, at given concentration, C per power C, and this D per power D, and this A per power A, and this B per power B, like this. So here the number of moles or coefficient is 2. We write here 2 over the concentration term. This is very important thing. Now this is copper solid, this one, and we write here Ag plus aqueous, and this is 2. This one, right? This solid and solid, this Ag solid, and this is copper solid. Active mass is equal to 1 in solid state. So what we write finally? What we write finally? E cell. This is equal to E0 cell. Now we put the value of this one. E0 cell minus 0.059 by 2 log, and this side is copper 2 plus, and this side is Ag plus per power 2, and this is calculated 1.46 minus 0.059, and this is 2. What was the concentration? Let I erase it completely. If it is probably 0.01, but so you are 0.1, and if it is given 0.001, then it will square. So you will solve it, and solving it, solve taking the log, and then it is unit is E volt. So it can be easily solved, or this is equal to 0.46 minus 0.059 by 2 log whatever be the value. What value comes in my mind, I have written here. You write the value as per the given in the question. So this is 0.01 and this is equal to 1, 2, 3, 4, 5, 3, 3, 6 and this one this 1, 2, 3, 4, 5, 6. You solve it. So 0.46 minus 0.059 by 2 log 10 to the power 4, that is equal to 0.46 minus 0.059 by 2 into 4 log 10. So by putting that value we are able to solve and the unit will be in whole. So I think the Nast equation you are able to solve the problem on the basis of Nast equation, because this is very important one. In every examination the problem is asked from the Nast equation. So we should have the clear concept. I have given the knowledge in the Zoom online classes by Zoom, but it is not very easy to say, because only there was no blackboard work. I was totally based on the book, and what you see there, that was I was discussing on that one. If I do the work on the board, I think it will be helpful for you, and it will depend on you how much you are interested to solve the problem. If you are interested, no one can stop to achieve your goal. Now we consider another topic. Now we take another topic. I erase it completely. Now we take another topic, equilibrium constant and Nast equation. Equilibrium, Nast equation and equilibrium constant. Equilibrium constant. Let me consider a cell, and that cell is in equilibrium. Consider a cell Zn, this is solid, this is Zn2 plus aqueous, and this is copper 2 plus. This is a common example of the galvanic cell, and this one is copper. So the net reaction of this cell, Zn solid plus copper 2 plus aqueous, is equal to, this is Zn2 plus aqueous, and this one is copper, that is solid. So we write the Nast equation for that cell. Nast equation, if we write it for that cell. Now E cell is equal to E naught cell minus 2.303 RT by NF, as we write it, NF, and this is log, this one is product by reactant, Zn2 plus aqueous, and this one is copper solid. Now this is Zn solid, and this one is copper 2 plus aqueous, this one. This is. Now when the cell in equilibrium, under what conditions we see? In the equation, when the concentration in this cell, when the concentration of zinc ion increases and the copper ion decreases, the cell potential E cell will decreases, and a time will come when there is no flow of electric current. When there is no flow of electric current, means E cell is zero, the cell is assumed to be in equilibrium. So at equilibrium, E cell is equal to 0. So we can write it as E0 cell, that is 2.303 RT by NF, and this is log, and this one is AA, again I write it BB is equal to CC plus DT. So Kc is written as Kc is equal to C per power C and D per power D is equal to A per power A, and this is B per power B. So log Kc, solid is always, solid is 1, Zn2 plus aqueous, and this is, so Zn copper 2 plus aqueous. So this is Zn solid, Zn solid is 1 active mass, and copper solid active mass is also 1. So this value is written as E0 cell is equal to 2.303 RT by NF, and this one is log Kc. This is written as Kc. So we have to calculate the Kc. So this is equal to log Kc. Log Kc is equal to E naught. This is the one expression, right? E0 cell. Log Kc is equal to E0, that is cell, into NF, and this one is 2.303 RT. We can write it in this way, right? And Kc is equal to, therefore Kc is equal to anti-log of this one whole factor E0 cell. There is a table in your book, anti-log, or in the question paper value of anti-log is given. We can easily solve it. 2.303 RT, like this. This is that. Now this is another form. It can also be write by solving this part. So let it be erased. See the problem. Suppose this equation is E0 cell. Now putting the all value, this one is 2.303, this is R8.314, 298 Kelvin, and this is N and 2F 96,500 coulomb per mole, and this is equal to log Kc. On solving these values on solved and solved in so many cases in the last equation, that value comes to be 0.059 by N, and this is log Kc. So we can write here as log Kc is equal to N into E naught cell by 0.059. So Kc is equal to Kc is equal to, we can write here as, so this Kc is equal to anti-log of this is N into E naught cell by 0.059. Now in this, when we in the problem, if it is asked to calculate the Kc for that equation, suppose it's the same equation. This is we take at example. This is Ag plus twice Ag plus aqueous plus copper. This is a solid, and this copper 2 plus and plus twice Ag, right? And for this equation, for this equation, E0 cell is given. E0 cell. E0 cell is given. If it is not given, then we calculate in the same way E cathode minus E anode. That is, it is 0.46 volt. And the question is that you calculate the case. Suppose this is the problem. How can you solve it? You think over it, right? So what is the formula? Kc is equal to direct this one. And from where we calculate the En, because in this charge is 1 and here is 2, multiplied with 2 as discussed in the previous example by taking this one. So N totally is 1. Here N is equal to 2. Now write the equation directly. That is anti-log of that is 2 into 0.46 and this is 0.059. On solving it will come some value. So it can be solved. Suppose how we will take the anti-log. How take anti-log? Take anti-log. Suppose it comes to be 10.15. Let this one. This is the anti-log of this figure. So here, so we write here 10 to the power 10, and we see the anti-log of 0.15. Let suppose the anti-log of 1.5. Suppose 3, 2, 5. All are assumption. This is assumption, not the correct value. Assumption. So it is come to 356. We put here this one, and this is the value of the Kc. This is the assumption. So you will solve it. Whatever with the value comes, you take the anti-log from this log table, anti-log table, and we are able to finally find out the value of Kc. Now we come in the another topic. Now I want to discuss another term because I put the video in pause mode to clear the board. Then, so gives free energy and electrical work done. This is the topic. Gives free energy and electrical work done. Electrochemical cell and gives free energy. The heading in your book: electrochemical cell and gives free energy. Electrochemical cell or a galvanic cell. As for free energy or a galvanic cell. Electrochemical cell, that example is suppose Zn, right? This is Zn2 plus. Example like this, copper. This is 2 plus, and this one is copper. So how cell potential of the cell and the gives free energy are related, we have to correlate it. So electrical work done in 1 second, W electrical in 1 second, 1 second if we take, that is potential difference into potential into total charge. If we carry out the maximum work done from a galvanic cell, then we have to supply the charge reversibly in order to do the maximum work done in order to supply the charge reversibly. So this is the maximum work done by a galvanic cell is equal to decrease in any W electrical is equal to decrease in free energy. Decrease in free energy. That is called gives free energy. May I write it? Gives free energy. So decrease in free energy, that is minus delta G. And W electrical is equal to, that is Q, that is the charge, and the E cell. This Q is equal to NF into E cell. So this decrease in free energy delta Z, we can write it that is minus NF into E cell. For this cell, if Zn 2 plus ion concentration and copper 2 plus ion concentration is equal to unity, then what will happen? E cell is equal to E naught cell. So we can write it that is at standard condition. So delta Z is equal to minus NF E naught cell. So if the value of E naught cell is known, when the concentration are same, the value of N, number of electron lost and gain, F is the Faraday of electricity, 96,500 coulomb per mole. By putting that value, we are able to calculate the value of the Gibbs free energy chain. Gibbs free energy chain, I had discussed that Gibbs free energy chain gives the criteria for the feasibility of a reaction, whether the reaction is feasible or not feasible. For a reaction to be feasible, E naught cell that is must be positive, or E cell that comes to be positive. It comes to be positive, then delta G comes to be negative. When delta G comes to be negative, the reaction is feasible or the cell is feasible. Reaction is feasible or the cell is feasible. So if the concentration are different in terms of E cell, we calculate and we calculate the free energy. When the concentration are same, then we put, that is we calculate the E naught cell, and E naught cell is calculated by what? That is E cathode minus E anode. Putting this value, we are able to calculate this is Gibbs free energy chain. So this is the relation electrochemical cell and Gibbs free energy. So today's the topic is last. In another topic I will, because these all are the mathematical topics. So there is some mathematical problem still left in another topic. So this is the need to discuss in the board. Otherwise theoretically it is very difficult to narrate the things verbally. So when you will go through the book, there are problems given in your book, you try to solve. I hope sure you must be able to solve the problem if you will go through my video. So this is now I would like to thank you for your patience listening, and I hope you will like and you will share maximum, and rest is okay. Thanks a lot.